Mr. M, known as the Knowledge and Science Academy. Of course, we're going to continue. Hey, scenario 2 was intense. Scenario number 1, rather, was intense. I know. I was getting a lot of texts saying, say, thank you. A lot of people, meaning a lot of people understand it. And a lot of people understood it, right? I don't know why, man. I must speak. Can anyone teach me Venda or like other languages like Sutu, Bedil, so I can speak those languages? Because English, it's not my things. It's not my things. You know those. Okay, let me do that. Do you know? 1 minute. I'm just playing. Let's continue. So, so yeah, no jokes, right? We have scenario number 2. Scenario number 1 was intense, but it was a very good start for us to know that basic, right? So that I won't have to explain. Where's this thing? There's graphs over here. Yes, this was a struggle. I won't have to explain these graphs. I'll just skip over them because, of course, I won't skip over them. I'll be explaining the graph according to the scenario, but in this scenario, of course, it will be a different graph, but the same principles on the velocity time graph will still apply. Those principles that I taught, right? Now, of course, scenario number 2 says that it is a ball thrown from a height and not caught at all. Now, what you must remember, right? When we throw a ball, when it returns at that same height that it was thrown, the velocity will be the same, but in the opposite direction. Angit, do you agree? Yes. How do you see that? Because if we treat this as a ground and we throw this object, when it returns at the same level it was thrown from, the velocity is going to be the same, but in the what? In the opposite direction. Right? So you see now that scenario number 1 helps us understand scenario number 2. Right? Now, this here is the point where the graph changes the direction. We call that what? The maximum height. And now what is special about the maximum height is that we know already that at the maximum height, the velocity is what? It is 0 meters per second. Right? Now, of course, we say that the object is thrown, so the initial velocity has to be greater than 0. Right? It is projected. It is given an initial velocity. Right? Now, if the object is not caught, the object, of course, it will continue and reach the ground. Now, the object will have a final velocity that is greater than the initial velocity. Why? Because it has gained more momentum. Right? And that's why I was doing momentum first, so that I can be able to explain using principles of momentum over here. Right? Because when you do balls that bounce, you're going to see when I explain elastic and inelastic collision, you're not going to be now, what is going on? Because I've already taught you these things and I've broken down in the way that people are saying, there's no way I'm feeling momentum. So you can't be the only one who's having a problem with momentum. You have to put in more work. You have to rewatch the videos. You have to ask questions. You have to ask for help. You have to do past papers. And then trust me, we have to master the content. The aim is not to rush through the topics. That's why I do not rush through the topics, so that we can master the content, so that I always start with the basics, break everything down in a way that when we continue, you always have that basic at the back of your head. Now, let's continue, right? Now, the velocity that it strikes the ground with is going to be higher than the velocity it was projected with. Young piggies, try and do it with calculated with the object at your home. No, I'm just playing, guys. But just know that the velocity final, when it reaches the ground, is going to be greater than the velocity it was projected with. Let's say, for example, the velocity was 5. The velocity here should be maybe, let's say, negative 20. Why is it negative 20? Because it's in the opposite direction, and the first direction of the ball is what? Is up, meaning that the first direction is the positive direction, so it's going to take up as what? As positive. Are we together? Sharp. Are we together? Sharp. Why? Because I told you that you always take the first direction is what? As positive. Now, if you remember, we have gravitational acceleration. It is what? It is 9.8 meters per second squared downwards. Right? Now, if up is positive, then down is what? Say it. It is negative. So, if this one is going downwards and we chose downwards as negative, my gravitational acceleration should be negative. For all the questions that I'm going to do in this VPM scenario, You do the same in an exam. You choose the direction, you consider the G, and then you write it so that you don't get confused as you move on. As I said, just because the ball changes direction and whatever doesn't mean that changes. There's constant, as it says, gravitational constant. All right, guys, how? It's constant. It doesn't change. It remains the same. Right? Now, let's continue. Right? Now, if I'm speaking about the time, right? The time it takes for the ball to go from A to B and the time it takes for the ball to go from B to C are going to be equal. Why? Because this part over here, this portion over here, is just scenario number one, right? The ball is projected, reaches maximum height, comes back at that same point it was projected with. It has the same velocity it was projected with, but in the opposite direction. That is just scenario number one. So the T1 from here and the T2 in this scenario is going to be the same. Right? Now, we spoke about displacement, and I gave you an example where I said that you go from A all the way to, you go from A, which is this point, and then you go all the way to point B. I said that the distance is where the curve's over there, but I said to you the displacement is from here, from point A to point B in a straight line, right? So when we speak about the ball displacement, we look from where it started to where it is, right? So now when I say to you, what is the displacement of the ball of the entire motion? Where did the ball start? Here. After the motion, where is the ball at? On the ground. So the displacement is from here to here. That's why displacement will never be the same as height or distance, because the distance that the ball traveled is this, the whole of that. But the displacement, which is delta y or delta x, is just from here, from A to D in a straight line, right? I know this doesn't make sense. I know no, it does make sense, because I explained the displacement in the first scenario, and I did that very well, right? So now you must remember this. The graphs are always going to be there. The graphs are always going to be there, right? So let's say, for example, let me make the displacement. If they say calculate the height of the building, you know that the height of the building will be from here to here. But also, what do you know that goes from here to here? It's the displacement of the ball for the whole motion. It's from here, to this point, to point D, right? In a straight line, So you could calculate the height of the building by just calculating the displacement from A to D. Oh, guys, physics and math are the best subject ever, but it's fine. Let's continue. I love what I'm doing. Now, of course, you also have to draw graphs for this one also. Now, velocity, position, time graph. This is the position time graph. Those who know the position time graph. Now, what is key about the position time graph and what you must remember is that it always takes the motion of the what? Of the ball. Now, if we take up as positive and down is negative, I want you to look at this. Now, the ball is going up, right? It's going up, reaches maximum height, then it's going to come back to its original point. Right? Now, why are you starting at 0? Because you have to take this ground or the height at where it was drawn as the 0 as reference point. This is where you take the 0 reference point, right? I'm also going to be taking doing an example where you take the ground as a 0 reference point. So where we start is our 0. That's where we start, at the height, right? Then when we get to there, our displacement, we are going to be continuing, right? Now we go away from the 0 and go below. So we displace way down than where we started, right? We started here. We are lower now than where we started, right? We're going lower than where we started. So our displacement is what? Is negative. Why? Because we chose up as positive, meaning down is negative. So our displacement is negative, right? So our displacement has to go in the negative direction. Do you get me? I'm sure you get me, right? just like that. Now, if they say maybe you would go into, let's draw our scenarios. Let's draw A. Where is A? Over here, right? A is the start. Where is B, which is the maximum height? This would be B. Where is C, which would be the same point that we have projected from? That would be C. And D would be where the ball reaches the ground, right? Now, if you take the ground as the reference point, meaning that this height, this will be starting at a particular height. It means that we have to start at a certain height. Let's say that height was over here, right? Now, what we're going to do is maybe start from there, and then we're going to go up, reach maximum height, and then go, and then we pass the same point that we are projected from, which is this one, right? And then we go to our zero reference point, which is the ground. So that's how you would have drawn it if they said take the ground as the zero reference point. So you know that, okay, this is my ground, and I know that over here I have my displacement as 0, because the ball is neither down, there's no distance between the ball and the ground, right? So there is no displacement. The displacement there is 0, right? Now, there's nothing special about this one, right? If the ball was not caught, it goes to that same point, then it goes down to the ground. If you take the ground as a 0 reference point, you start at a certain height, go to maximum height, then you go back to your ground, which is the 0 reference point. So it's two scenarios. Let me label them. So when you say the red one is when you take let's say you take the top of building as 0 reference point. Now here, this orange one is where you take the ground as 0 reference point. I know you will be able to digest that when we do past papers, but of course the video is going to be there. So it's there for you to do what? To rewatch, keep watching until you master the content. Right? Now, the velocity time graph, there we know. This doesn't take the motion of the object, but what it does is that it doesn't take the direction of the motion. It takes a straight line. It is drawn as a straight line, right? So what the object does, right? What you do when you start at a certain height, because it is drawn upwards, right? So what is going to happen is that the ball is going to go up, right? When it goes up, it reaches maximum height. After reaching maximum height, what is going to happen is that the velocity is going to be 0 at that point. The velocity is going to be 0. What did I say? I said that the ball is going to be, let's label for A and B, C here. I'm thinking, that's why I was trying to think, would have done the same things. So here, this would be starting point A, this would be our maximum height, this would be C, which is the same point that we projected from, and D will be the ground, right? So look at it like that, right? Now, now I'm fine. I'm satisfied. I'm thinking, is the lesson going the way that it should go, right? The ball is going, because remember the motion of the graph. So let's draw the motion before, right? The ball is going to do what? Go up. When we go up, what does the velocity do? The velocity, it decreases until it reaches 0. Now, after reaching 0, we go down, but we're going in the positive or negative direction. In the negative direction, because we chose up as positive, meaning downwards movement is negative. So we need to have the negative part increasing in the negative part, right? Then we reach the ground, right? Now, what you must take note over here is that if you have T1 over here, T2, the area of this graph and this graph are not equal. Why are you saying that, sir? Because there you said they are equal. Yes, because there the time it takes to go from here to here was the same, but the time it takes for you to go from here to here, it's not the same, because this means that you're saying the time it takes from you to go to from for you to go from here to here, and the time it takes for you to go from here to here is the same. That is not the same. Well, let's label it. That's A, B, C, D. You meaning that the time it takes for you to go from A to B and the time it takes for me to go from B to D is the same. It is not the same, right? You can see the distance here is very, there's a big difference in terms of the distance that must be covered, right? So the areas are not the same, but we still use the same area, that the area is 1 over 2 VT. But we know that the area, when they say use the graph to calculate the displacement, or you can just use the area. We know that the area calculates the displacement. I'll show you when we do past papers. Now, also the same thing, the gradient is still acceleration. Acceleration is rate of change in velocity. You still use the same principles. Now, as you see over here, we should label it. The graph was going where? This is A, the starting point that it was thrown from. This is B. I hope you've drawn the scenarios in the book, right? B, which is the maximum height, and C would be somewhere over here, which doesn't matter, which is the point that the graph maybe where the ball reaches the same point it was projected from, right? Then D would be the point where the graph reaches the ground, right? Now, this one, I said I'll show you that it always stays constant, right? Let me prove to you. What did we choose as upwards? We chose, what did we choose as positive? What am I saying? What did we choose as positive? We chose upwards. So meaning that a downwards is negative. So we have negative 9,8. Why? Because 9,8 always goes where? Downwards. But we chose downward as what? As negative. So 9,8 should be negative. So what we're going to do over here, let me remove that. We're going to have a straight line over here, because the acceleration stays what? Constant. I said to you, it stays what? Constant. It doesn't change. It doesn't change, right? So I want to see and take notes. Of course, here there were not so much notes because the focus was only on the graphs and a little bit of explanation here and there. This, guys, is scenario number 2, and of course I'll see you